This video will work through problem 14.5 of Gapenski's Healthcare Finance, 6th edition. Okay, in problem 14.5, we're evaluating two projects. They both have the same initial investment of $10,000, and we're going to calculate their payback period, their NPV, and their IRR, and compare the two. So project X has 4 years of cash flows. In year one is the $10,000 outlay. In year zero is the $10,000 outlay. In year one, we earn $6,500. In year two, we earn $3,000. In year three, we earn $3,000. And in year four, we earn $1,000. So the first question is, what is our payback period? So we start with negative 10,000. Then we earn 6,500, so we're still at negative 3,500. Then we earn 3,000 more, and we're at 500. Then we earn 3,000 more, and we're at 2,500. So we break even sometime in year three. Now, how much do we have to earn in year three? Well, we have to earn that $500. Well, if we earn 3,000 in year three, how many months? What percent of year three do we spend trying to earn that $500? Well, it's going to be 500 divided by 3,000, which is 0.16. Right? Yeah, 0.16, repeating. So then we take the 0.16 plus the 1.2, and we have a payback period of 2.16 years. So now we want to calculate the NPV, and I'm going to use my cash flow register to do that on my calculator. So I have a initial outflow of negative 10,000. Year one, I earn 6,500. Year two and three, I earn 3,000. So I'm going to set FO2 to 2 because it repeats once. Then in year cash flow three, which is year four, I earn 1,000. And so that's it. So then I go to NPV and I tell it, well, it's a 12% cost of capital, hit enter, and then compute the NPV, and I get 966. So the NPV equals 966. So that means this is a viable potential candidate. Doesn't mean it's the best one, but it is viable. Okay, now we just do IRR, compute, and our IRR is 18%, which is greater than 12%, which is our cost of capital. So that means it's viable. Oh yeah, and NPV is greater than 0, so that means it's viable. So this is a viable project. Now the question is it better than project Y? Let me see. We'll just do project Y right next to it. So project Y is a bit simpler. $10,000 outlay, $3,000 per year, all 4 years. So its payback is going to be, so we start with negative 10, right? Then we're negative 7 at the end of year one, negative 4 at the end of year two, negative 1 at the end of year three, and then 2,000 at the end of year four. So we break even sometime in year four, and we have to earn $1,000 to break even, and we earn 3,000 in year four. So it's going to be 1,000 divided by 3,000, which is 1/3, or 0.33 repeating. So our break even is 3.33, 3 1/3 years. So it's a longer break even, so it's less appealing for that. Now we can do the NPV. Clear the cash flow just because it's easier. So our initial outlay is a negative 10,000. Hit enter. Our cash flow one is 3,000. Right, and hit enter. And then it repeats 4 times. So FO1 is 4, and that's it. So then we go to NPV, still a 12% cost of capital. scroll down, and then compute NPV, and we get negative 888. So that NPV is less than 0, so that means that this is a no-go. The IRR is going to tell us the same thing, but in a slightly different way. So we just hit IRR, compute, and so our IRR is 7.71, right, which is less than 12%, which is our cost of capital. So that's also a no-go. So the better project is Project X because it has a shorter payback period, it has a positive NPV, and it has an IRR that exceeds the cost of capital. Now, we can do this using Excel as well. So let me switch up a little bit here. And okay, so I've gone ahead and set up the example here in Excel. I've got problem X, and so I'm not going to bother with the payback because it works the same. But if we want to do NPV, so we would calculate NPV is equal to, and we can do that a couple of ways, but let's do the first one is going to be, we want to have, we're going to set the value, the present value of the cash flows equal, we're going to take the present value of the cash flows minus the $10,000 initial investment, or so we'll add the negative 10,000. So we do 10,000, D4 is 10,000 plus NPV 0.12 for the discount rate, and then we select the cash flows, and then we hit return, and we get the same answer as before, 966. Now the other way to do this would be to say, okay, the initial outlay is 10,000. How much is the first cash flow worth? Well, it's equal to 6,500 divided by 1 plus the interest rate, which was 0.12, raised to the number of years it's being brought back, and that is just 1. So we have that, and then we can copy it down. And if we sum this column now, we should get the same NPV. And it's 966. It's not, it's rounding. So we can make it neat. There you go. All right. And then IRR is just, you use the IRR function and you get 18%. Now we can just kind of, I think we can just copy this over. Let's see if that'll work. No, it won't work. We got to redo. So that's just, so for Y, it's just 10,000, and then it's 3,000 divided by 1.12 raised to the 1. And then we just copy that down. And so our NPV using the kind of manual method tells us that it's negative 888. The using the NPV formula, we start by taking our initial investment, plus we calculate the present value of the cash flows using the NPV formula, and we get 888, right, again. Okay, and then IRR, we just highlight everything. It's an easy one, and we get 8%. So just to get it to be, to match up with the book answer, it's really 7.7%. Okay, so that's using Excel. And that is 2 different ways to do problem 14.5.